A jungle, a waterfall, a mall or an airport. These are questions that when you arrive at Singapore's airport, you will probably ask. Stay in touch with Parametric House and learn lots of stuff about parametric world. Under the amazing new glazed dome at Singapore's Jewel Changi Airport, Safdie Architects design an indoor garden sits with a large waterfall running through the middle, called the Rain Vortex. The 40 meters high indoor waterfall is the largest in the world and can channel 38,000 liters of water in a minute. A canopy park has nets for bouncing and walking strung as high as 80 feet above the ground. A forest of 1,400 trees provides greenery and shade. Jewel Changi Airport reimagines the center of an airport as a major public realm attraction. Jewel offers a range of facilities for landside airport operations, indoor gardens and leisure attractions, retail offering and hotel facilities, all under one roof. The building utilizes rainwater as it's pumped through the waterfall and used throughout the airport for building services and landscape irrigation system. The Oculus and flowing water also act as a passive cooling system. Inside, a lush forest interior climbs up the sides of the glass dome structure. So, stay with us for learning how to create it in Grasshopper.
Okay, before we start the tutorial from scratch, let's take a look at how we can define this roof from the Singapore Changi Airport Waterfall. So I'm going to define three different points, which will define the location of three different ellipses, and we're going to talk about that in this tutorial. And then we can locate the radius for the first radius and the second radius of this ellipse. You can see that by keep changing this, I can change the form of this roof surface, and by changing the point we can change the form. Second one also, we can move it up and down. Okay, and by defining the surface, then we will define a division, which we will use the Launchbox plugin to produce that. Be sure to watch the video till the end, because first of all we're going to talk about the basics of how we use this Launchbox plugin, because when we use the Launchbox plugin Triangle Panels B, you can see that we will have a problem at the seam of the surface. Then we're going to use several steps to find the panels on the seam of the surface, okay, and fix that, and then finally reach the final surface. Then we're going to also use an offset, and I'm going to explain that and the Launchbox plugin to produce the structure. As you can see, let me just zoom in on the project, and you can see that we can produce this structure and the frames with the Launchbox plugin. We're also going to produce the windows, which will be located on the frames. Okay, so let's get started from scratch. What I want to do is to define those 3 points. Let's just bring the perspective view here. And let's go to the params menu, select the point and put it here. I'm going to put the bifocals plugin so you can see the names, and I'm going to define 3 different points for the ellipses. So just right click and set multiple points. Maybe the first one is 0. We can snap on the 0 and use the control key to bring it up. Again, use the control key to bring it up like this, and right click, and we have these 3 points. Okay, if we go to the curve and in the primitive, you can see that we have this ellipses here, which uses a plane, which I'm going to use in this project. And when you connect a point to a plane, it's going to assume that this point is the center of an XY plane. So remember that this is the trick you can use, and connect it to the plane. You can see that's in the XY plane. Okay, we can define different radiuses for the first and the second radius. That's going to give us an ellipse because we don't need something like a circle. We can go to the Params menu and use the gene pool, which can give us a collection of number sliders. Double click on it. We want 3 number sliders between, I don't know, maybe just 1 to 20. And if I give it to the radius 1, you can see that this is going to change the radius 1. And then we can just copy this and bring it to the radius 2. Okay, to make it an ellipse, we can just make it bigger in the radius 2, maybe like that. And we don't know how to make the surface, so to produce the base surface, let's connect these ellipses together with a loft. Go to the surface tools, and in the free form you can see there is a loft which can just connect those ellipses together as a curve. Okay, first of all, the point here is going to go down on the ground like this. Then we can see that this is for the first one, this is for the last one, so let's make it smaller. This is for the last one, and you can see that we can control that. Okay, that's for the ground. We can just bring it down more like that. The first one has to be a little bit bigger, so we can make it like this. And the second one, based on your project, you can control the location of the ellipse and also the radius like that. Okay, if you want to rotate these ellipses, you can by doing a rotation. For doing that, we have to do a little bit of trick here. We can say an XY plane and give it to the origins, so you can see that there is an XY plane. And then we can say we want to rotate them around the X. So let's say rotate 3D. Just a little bit of control if you want on the planes. So we want to rotate this plane. The center of rotation is going to be the center of the planes. We can give this or give the points, doesn't matter. When you connect a plane to a point, it's going to say it's the center of those planes. The axis of rotation here is the X, so I'm going to just say unit X as the axis, and then we can say a degrees. For example, we want to rotate these planes from -30 to +30. Just to give you an overview of these planes that you can see that I'm rotating here. I guess that we have to rotate them around Y, so just let's change this to Y. It's going to give us a better plane. That's it, and now we can give that to the plane. So you can see how easy it is. For example, for the ground section, we don't want it to rotate, so it's going to be from 0 like that. We don't rotate that. The first one is also 0. Maybe we want to make the second one a little bit tilted like this, right? So you can rotate that too, but let's just say from 0 to 30 and put all of that to 0, so you can just control that later. And remember, you can play with these numbers. Okay, that's a good thing to get started for the surface. Okay, now if you look at this picture, you can see that these panels are connected. These panels are triangular panels, and their direction is up and down, right? So we have to make this also in Grasshopper. There are many techniques you can use. You can also use plugins, but I want to show you how you can do that without using any plugins and do it from Grasshopper and from scratch without any plugins. So the technique I have used is you can do that many ways, but for now, this is the way I have used and wanted to teach you this technique. I want to go to the surface utility and use this ISO trim. Okay, so I'm going to give that to the surface, and this ISO trim can divide the surface into strips. So by typing divide domain 2, giving the surface to the surface input of the ISO trim, the loft to the domain, and here to the segments. this is going to divide the surface into the UV counts. We have used that before, so if you don't know about this, you have to watch other tutorials about it. But for now, it's really easy. By combining the surface isotrim divide domain 2, you can give it a U count and a V count. I guess one of these have to be 1, so I can give it, to write this number, you can just double click 2 / and type a number, for example 1. It's going to give you a panel with a 1. And if I give it to a V count, you can see if I give it to a U count, it's going to be this way. And if I, the control key, disconnect that and give it to a V count, you can see that this is the exactly strips we need, okay? And we can say from 3 to 20 maybe, and increase the number of strips we have. So this is the technique we want to use. And let's just go and turn this off. We have this strips by using this isotrim technique, and that's really great. The next step is, because this panels is, one of them is up and down, and the other one, let's just draw this with red, direction is changed. We have to convert these strips into 2 groups. We can do that by typing this patch. We have talked about this patch thing. If you don't know, just watch this small tutorial. But for now, if I give that to the list and the default pattern is a true false, this is going to divide this strips into 2 series. The list A, which is the list of trues, and the list B, which is the group of falses. That is really cool. You can see we have 2 series of strips. The next step is to divide the edges of the top and the bottom into points. So I'm going to go to the surface and use this deconstruct brep tool. Deconstruct the strips. Let's turn this off so you can see what I'm doing with the strips. It has 3 edges, obviously, and the reason we have 3 edges here is it has an up, down, and the seam, right? So we have to go to the sets list item and pick up the edges. I'm going to pick up the first edge, second edge, and the third edge. And obviously we have to go with the second and the third one. And let's divide them. So I'm going to go to the curve and use this divide curve tool. Divide this one and this one from maybe 3 to 30. Give it a count and increase the counts. Okay, that's the number slider we need to define the division. Okay, it's going to help us. And let me show you a strange thing. If I go to the points display and use this point list tool up here in the vector section and connect it to these points, bake it so you can see the numbers. You can see it's like 0, 1, 2 till the end. And if I connect it to the down part and bake it, you can see it's like 0, 1, 2 till the end. So these numbers, the reason is that when you draw a NURB surface and deconstruct it, the edges has directions. So this is the direction of this edge, and sometimes it's clockwise or anti-clockwise. So you can see that these directions, 2 edges are not in the same way. Let's fix that by going to the curve and using this utility called flip curve. We can flip this second curve, so we will be sure that these directions of the points is the same. You can see 0, 1, 2, 3, 0, 1, 2, 3. Okay. Now what we have to do is to again dispatch these points. For example, for the bottom, we don't need these and this point, but we need these points, right? And for the top, we need these points, well, but we don't need these points. So again, a small trick, dispatch, and now let's just see which points we need. Let's turn this off and connect a point to the list A. If we select the list A, obviously we have to go with the list a B with the second edge. You can see it here, or you can go with the list B and go with the list A on the second edge, for example. This is going to be flipped for the next strips, so be sure to trick that point with the next strip we will use in the second part. So now we have these two set of points. This is really cool. You have to weave them together. Splitting this surface with the polyline is going to be some problem. Let me just show you what I mean. If I use a tool called Weave, and if you want to know more about these things, you can also enroll in our course. We have a complete section of data management. But for now, if I weave these two series of points together, that means one from this one, the second from the second stream, again from the first stream, the second stream, and use this to go to the curve and use a polyline. Let's just flip this streams so you can see it. Okay, so it's going to be 0, 1, 0, 1, 0, 1. And then we can close this polyline too. This is a technique we can use. Turn everything off. You can see that we have made this polyline on the strip. But the problem, if we wanted to split the surface with this polyline, is this. If I go to this intersection, physical, and split the surface with this polyline, that means we want to split this strip. With this one, remember to flatten the input, so all of those intersecting polylines are going to split it. The problem here is that it's going to give you those panels. First, it's going to be a curved panel we don't need. The second one is the problem with the seam. You can see that the seam is going to split it. So that's why I want to teach you how you can start to make panels with these polylines. It's really cool. Let's go and do it. Okay, the things I want to do is to flatten these polylines so all of them are in one group. So you can see we have 6 polylines. If you don't know about flattened graphs, we have a free video here in our YouTube channel. And if you want to learn more, you can go to our course and check out the data management section, a complete series of tutorials for that. Okay, I'm going to go to the curve and split this polylines here with the explode. And what's going to happen, it's going to make those polylines into segments. The trick I'm going to use is that I'm going to connect 2 of these polylines together and use that to make the surface or the panels. And then we can shift it and use these 2 polylines to make the second one. So let's use a tool called, obviously this tutorial is going to show you lots of tools you can use in groups, but for now we can use the partition tool, partition list, and convert that into sizes of 2. That means that these polylines, convert them into group of 2, then we can join them with the curve utility. So let me just explain what happened. We had a polyline, right? We exploded that into lines. Then we picked up 2 of them, I mean this one for example and this one, and put them into one group. Again, yellow, this one and this one into one group. So that's going to help us to make these set of small lines. And if we want to make that into another section for the V's, is to use another tool. This tutorial is full of insane data management. Shift list, and what's going to happen is that this one is going to be from 0 is going to shift to this one. So I'm going to shift list the segments with a shift of 1, and then again divide that into 2 and join them. Let me show you here. If I bake this, you can see that we have an arrow up polyline here, and if I bake this one, we have an arrow down. These are the polylines we're going to use to make the panels. Okay, we are good to start this. I'm going to flatten, and I say Doesn't matter which groups they are in, we just want the connected polylines. That's it. And now I'm going to explode them. This is the technique I can use without using any plugins. And now each of them has 3 vertices. First one, second one, and third one. That's going to give us the panel. That's the way we can use that. Okay, now we can go to the sets, and with a list item, pick up the 3 edges. And now from the surface, by using this tool, 4-point surface, we can make it. So that's the technique we can use. Like that, and then copy paste this for the second set of vertices. That's it. To tweak the algorithm a little bit, we have to play with the division. You can see that when we put that into even, the numbers is correct, and it's odd, it's giving us problems. So I'm just going to double click this number slider and put it to even numbers. So we'll always have a complete division. Okay, that's the tutorial of how we can use the panels. Let's just make a copy of this. Control C, Control V, and give this second series of strips to that. Let's turn this on. And now we have to fix these panels. So as I explained, we have to change the dispatch pattern. Here you can see it, and we have to also change the weaving pattern, maybe the first one and the second one. That's it. So remember, you have to flip the dispatch and the weaving pattern. That's how you can make the panels. That is beautiful. We can give this number slider also to the second group, so we don't have to mess around with this. Oh wait, when we change the numbers, that's going to give us the division. And another trick we have to use is the division of the strips. If we change the division, you can see it's going to give us results. And you can see that this is also giving us the panels. That was the tutorial of how you can make these panels. At the end, what I wanted to do is to give you a small trick of how to give it a little bit of thickness. I guess we have it here. Because I don't want to make it a long tutorial, let's go with, let's put all of these into one surface. I'm going to use the Shift key to put them all into a series of panels. And flatten this so all of them are in one group. Those are the panels we have. This technique is going to help you to make that structure like a little bit of accurate structure like for the Launchbox. This is really cool. Let's go to the Launchbox plugin. I'm going to use this panel frame. You can give it a number between 0 and 1, maybe like 85%. You should use that number. And we will have a series of frames. And let's just make that into another layer. And a series of windows. That's it. But if you want to give it a thickness, the problem is that these panels have different normal direction, and it's going to give you some gaps between them, right? How can we fix that? We can fix that by doing this technique. I'm going to just copy, paste. First of all, we're going to offset the surface, the main surface. I'm going to use the offset surface tool, which you can find in surface utility. Offset surface, give it to the left. This is the thickness of the structure. It's going inside. You can just change the direction by going to distant expression -6. That's it. And now let's just copy paste this from this part. For those things that you don't want to just change again, we can get rid of this with a control key. We don't want to change the numbers. We don't want to change this division. We don't want to change the panel's frame, and Control C, Control V that down, bring it down. And now we have to fix it by just right-clicking, locking the solver, giving the surface to here, to here. The UV division is the same. Let's check that out. Okay. These are the surface. Now let's just turn it on by turning off the lock solver. And check that if you want to see that those panels are the same. Why did I do that? Because we can just lock these together. It's a little bit tricky how you can do that. And let's just go to the curves. First, I'm going to give that curve to the panel, that windows. The reason is that it's going to give us the curves inside, and then we can loft them together. So if we want to loft each of them together, you have to graft and then loft it, because each of them has to be into groups. That means if I put that into a one curve data, you can see that this is like 2. That's it. That's really cool. We have the inside boundary. Now we have to also make the border of the outer boundary. So I'm going to just make a copy of that, turn off the solver, and now we have to give that surfaces curves around them. So if I want to show you, demonstrate how we can do that, we have 2 series of curves. The first one is this one, which we made a loft to the inside, and the second one is something like that, right? So we can just turn on the solver again. We have the border inside, and now we have to connect the frames to this. Let me just put this into EREP, the frame of the down part. Again, we have to graph this, so all of that geometry is in one group, and put it into one EREP with the Shift key. That means we want to connect 4 of these together. That's the outer part, the inner part, and the border of the up and down. And now we can join it to the surface, join. That's it. So we can bake that into layer 1. A little bit of calculation, bake that into layer 1. And now we can bake also the windows into layer 2. You can also download this, bake that into layer 3. Maybe we want to give it different colors. You can also download this example file from our website, but now if I just turn off the layer 3, you can see that this is the structure. It's really beautiful and easy to do that. If you want to really make that in the real world, it's a little bit more complicated than this lunchbox thing, but this can help you to understand. Let's just turn this off. Turn this on. You can see that we can make that. That's really beautiful. Okay, it has lots of details to make this in real life, but I hope that this somehow short and long tutorial will help you to understand how to model this in Grasshopper. Be sure to like this video so YouTube shows more of our videos to you. Thank you for subscribing to our channel. See you next time. Bye.